Hello everyone, my name is HARSHIT, roll number 21ME10036, and my other teammate is BHASKAR KUMAR, roll number 21ME10020. So for the assignment, we selected the problem number 1 of tutorial sheet number 5, where we are synthesizing the wiper mechanism with no quick return effects. And for presenting the simulations and the mechanism, we used a web-based technologies to do this project. In this project, we used HTML, CSS and JavaScript to accomplish our task. HTML and CSS were mainly used for creating the UI, which gives user a provision to change many parameters like length, angular, speed of the motor, etc., which you can directly see when we present our web page. JavaScript programming language was used to create the simulation. Now let us quickly see the computation approach of the synthesis. So the wiper mechanism is basically comprised of 4-bar mechanism, with the 4 bar named as base bar, motor bar, coupler bar and output bar. The wiper is attached to the wiper bar, which is an extension of the output bar only. A parallelogram linkage is used just to keep the wiper vertical throughout the motion. The motion was made to rotate at a constant angular speed, and based on that we calculated the angle of motor bar with the base bar at any instant of time. Now, as we know all the length of this linkage, we used cosine and sine laws to calculate all the 4 angles of quadrilateral formed by this 4-bar linkage. Then we drew the 4 bars at that instant of time. So in this way we drew states of the linkages in progression with time, and this made us see a simulation of the bar mechanism or wiper mechanism. Now moving to the further slide, we will see working of the simulators and user interface. The web page is quite interactive, giving us a range of customizable options to change the length of the 4-bar mechanism, wiper bar, angular speed of the motor and inclination of the wiper bar with output bar. Along with this, providing values of speed of the wiper, acceleration of the wiper, which is further broken into centripetal and tangential components, and the area wiped by the wiper. Visual include the speed and acceleration plot versus time of the wiper. Toggle buttons are those for toggling vector indicating the velocity in the green color and acceleration in the purple color, as well as centripetal and tangential components in the pink color. The user at any time has the freedom to start and stop the simulation, as well as reset to the default configuration, which makes the task very easy and interactive as well. Now let us directly dive into the web page. And in the web page, as you can see, we have 3 columns: actuator, 4-bar mechanism and wiper. In the actuator we have angular speeds which we can control, and in the 4-bar mechanism we can also control the length of the bars. In wiper we have angles, wiper bar length, area wiped, speed and net acceleration. Net acceleration component has another 2 parts, centripetal and tangential. And in this column we can control the acceleration and speed, as you can see. Graphs of module of velocity and acceleration have also been included to get the better understanding of kinematic values or parameters. As we can see, we can live tune these parameters and can be produced instantly. Velocity vector and acceleration vector are also being marked, which can be toggled on and off. The length of the bar can be changed, that accordingly gives us the heads up. Full rotation of bar becomes impossible, that is when it becomes rocker because of the combination of chosen length. As a general trend that was observed, that the area wiped by the wiper increased with the increased length of the wiper bar and remains constant with variation of effect as shown in the speed versus time graph. The quick return ratio was obtained to be approximately 1. For the motion analysis of simulation, we have taken care of velocity, acceleration and the wiper and torque requirement of the motor. Now after this my friend Bhaskar will take over.
As seen in the code given, we have the lengths of the bars of mechanism, which can be very dynamically controlled by the user. As length of the 4-bar mechanism known to us, we can find all the angles of the quadrilateral. By using sine and cosine law, we can find the velocity and acceleration. For velocity and acceleration, we use the function num_diff. Hence, using function num_diff, we get that for finding the velocity, we differentiate the position vector of the wiper bar, and for finding the acceleration, we again differentiate the velocity function of the wiper bar. Now let's check the analytical analysis based on the mathematical aspect for the sake of completeness. Here the given displacement equation contain A, B, C as the function of length and angle. The displacement equation obtained is result of magnitude of vectors L2 to L4 having the length L3, and after time differentiating it, we get the velocity equation. Similarly, again by time differentiating, we obtain the acceleration equation. Now for finding the torque, we assume the constant load and moment is caused due to the constant frictional force. Now using the work input and work output, we equate to get the tau2 is equal to J into tau4, where J is the Jacob obtained as in the velocity equation. Thank you.